we could have that evidence to promote our business or promote legislation or whatever we want to do with that. All right, so we're going to prove that at the 5% level. So assuming the old mix is better, we're looking for the 5% least likely sample outcomes. So if we put our sample outcomes on the sampling distribution and sample mean difference, the null hypothesis says that if we new minus old gives us a negative number. Alright, so if we get a positive number, we're going to be suspicious of that. Or we're going to think, well, we might have really good evidence. The further and further we get here, we're going to think we have overwhelming evidence that we can reject the null and start using the new. So the least likely 5% outcomes under this assumption is in this upper tail. Rejection region, 5%. All right, what is the z-stat that separates the upper 5% from the bottom 95%? Z critical values, I'm sorry, what? 1.65. I like it. 1.65. Okay, great. So we want to find a test statistic, and if it is above 1.65, reject. So let's look at our sample data. All right, we have a sample mean difference. All right, under the assumption that the null is true, the sample mean difference would be 0. But we actually found a difference between this and this. And what's the difference we found between 180, 190, and 152?
29.8.
Nice. 29. 29.8. All right. 29.8. All right, so that's going to be the top line of our z-stat. So I'll start that now. So our z-stat, our sample difference, is 29.8. That's what we found is the sample difference. The null hypothesis says there's 0 difference. All right, so we're off by 29.8. And we want to know how many standard errors of difference that is. So let's go figure out what the standard error is on this sampling distribution and sample mean difference. So we have a formula for that?
Yes.
Good, and what does it come out to?
5.8586135. You just gave me everything.
Is that right? Take it all?
No, after the 5, another 8.
Okay. Alright. Well,
8, 6.
so store that in your calculator. I'll just leave it there for now.
Waste the 6, and it's an 8.
Okay.
8, 6, yeah.
Alright. So, let's divide that by our standard error. So 5.858 and change.
You don't need the 6. See, that's what I was doing, adding 4 numbers. You only need 3 numbers? Or 4?
No, you need them all.
That's what I figured.
Every single number. On to infinity.
Yeah, it's a lot of them.
What does that come out to?
5.08.
Yeah.
5.087. Okay. That is our z-stat. So let's plot that z-stat and see if it falls in the rejection region. Okay, that's above 0. It is above 1.65. It's way out here. Z-stat equals 5.087. Okay. What is our decision? Anyone? Reject. Yes, our decision is reject. All right, anything above 1.65, we would reject. Now, what do you think about that? This is 5 standard deviations above the mean.
Overwhelming statistical.
Overwhelming for sure. Well, anything over 1.65 would be overwhelming. It's like overwhelming. A z-stat of 5.087. Have you ever seen anything like that?
No.
5 standard deviations above the mean. Remember Vander Holyfield's pretty tall guy. He was 2 standard deviations above the mean. Imagine if you see someone walking around who's 5 standard deviations above the mean. What's, yeah, it's kind of sad. What's the p-value for a z-stat of 5.087?
0.00001 something.
Anyone have it?
I
It's- Right, what is it, Kelsey? It is off the charts. Yeah. It is so crazy. Alright, 0.000000000 something. It is so this null hypothesis is so unlikely to be true that I think we should definitely invest in the new pesticide as long as it's environmentally friendly. And increase revenue. Yes, Kelsey?
I have a question about with sample size.
Yeah.
And when they're so different,
Okay.
wouldn't that affect your, like, the results that you get from each
Yeah.
sample, because it's like almost double, it's like not
Yeah,
double,
yeah.
but-
So well, what we're doing is we're more heavily, we're trying to use our sample size to determine standard error in this case. And because of the bigger sample here, we're weighting that more heavily.
So when you're testing 2 areas, you don't have to do the same sample size for both areas.
Correct,
That's what I
Because
mean,
it's
like,
such a
Correct.
big number.
you would think you would want to do,
correct.
you know, like equally,
Yeah.
the same amount of people,
Yeah.
but.
It will- It will not necessarily affect the difference. You know, it'll make us more confident about the difference. And in fact, the bigger the sample size, the smaller standard error.
Yeah,
Remember that coin flip example? We said, alright, all we have to do is sample 20 students before it is absurdly unlikely that we would get an extreme result for our sample size. Because 30 students are not all gonna flip a coin and have it come up heads 15 times. Imagine if your sample size was 400 and not 59. What are the chances of, you know, of an absurdly, of a big outlier? Alright, good work. I'll see you tomorrow, or not tomorrow, next week. Regression analysis, I look forward to it, it's fun. Fun for everyone.
I didn't really mind this.
Right. Nick had fun tonight.
Actually,